Okay. Do I see a light bulb? Oh yeah, look at that. I got my light bulb right there. Okay, on that light bulb is my bright idea, and it's some science. So, what I'm going to do is I'm going to have a cup of water filled to the top, but just like that. Another cup of water, and sort of like a medicine dropper thing that you can like take water in and squirt out. So, first make sure it's filled to the top, but it's not going up a little bit. So, you're just going to squeeze it, and the water will come up. And then you're just going to put drops in at a time. And you'll wait till it forms a bubble. So it might take a little while. But if you're a patient person, not like me, I'm not very patient, you can do all those patient bubbles. But eventually it'll start to rise over the top. And what it is it's something, it's a tricky word, but it's called, excuse me, cohesion, sorry. But it's when it fills to the top and molecules, they're hanging onto the top as it goes over, but once you get too many, then it drops. So let's say you're at the edge of this, you're being hung on to somebody, and then somebody else falls, you catch them, and that person at the top can't hold it on for very much longer, and then eventually it'll overflow, because you can see there's a really big bubble at the top. And so once it overflows, oh, it's on the other side, it's overflowing on the other side almost. So that's like if those guys, the person at the top can't hold 5 people, only 2 at the most. So eventually it'll just burst. Oh, some water fell back there. So I'll do it here so you can see it more clearly. I'm not patient. So it's right at the edge. It's a pretty high bubble, actually. It's pretty cool. I never knew that it'd get that high. Oh, it almost went over. It's really high. I bet in the next 3 times it'll overflow. There. Oh, it went on the other side. I'll do it some more. It almost fell over on this side. Now time for the 3rd or 4th, I don't know. It's doing it some more. Uh-oh. So see, that one guy at the top couldn't hold very many people, and he let go, and so some water fell. But it's molecules instead of humans. So that's what I have with my bright idea.
Right, for our second bright idea, we're going to be doing an experiment involving displacement. So for this experiment, you're going to need some clay. Play-Doh might work too. A large measuring cup filled halfway with water, and a pipette or a measuring medicine tube. Alright, so what you're going to do first is make a ball with your clay. Just a small ball. And then put it in the water and see if it floats or not. It doesn't float. So take it back out, use the same ball that you put in the water, and try to make a little boat. So, it floats. Now take your medicine tube or pipette and put 1 drop of water in at a time. You'll notice that the water level on the outside is starting to rise as the boat is becoming heavier. Wow, this is a good boat. It still hasn't sunk. This is a very good boat. But you can see around the outside, it almost is coming in, but not quite. And there it sank, because it was heavier than the water that it was displacing. So I'll illustrate it again. It also is similar to why a very small pebble, like your ball of clay, sinks in the water, and why a large ship can float. Until if it starts to leak, that's why the Titanic sank, because it had too much weight in it, and it was heavier than the amount it was displacing. So there's your clay boat experiment, and my boat is sinking. And for more ideas, you could do a penny experiment, like the first experiment, where instead of dropping water into the cup, you could put as many pennies or paper clips as you could in. And so there's a lot of cool ideas. So thank you for bearing with us on our first show, and it's time for our light bulb.